Okay, good morning, friends. As part of the Big Data Engineer immersion training, at this time we are talking about Spark. So far, I have covered HDFS and HDFS in detail, and then MapReduce overview from both the concepts perspective as well as the framework perspective. Now we will get into the new topic called Spark. I hope other guys can hear. I think it is the issue only with Nagraj. Okay. So if you go to, okay, I need to stop sharing. If I stop sharing, there will be two windows, Quick Start and the other one under Quick Start. People have to use call using computer. Okay, so so let's start now. So today we are starting new topic, very important topic at this time, highly relevant to the current big data market is Spark. So today we will get started with Spark, and then about next week we will try to complete Scala as much as possible, and then we will see how the same things can be implemented using Python. Okay, it will take at least 2 weeks to complete Spark. Okay, so first thing you need to make sure is you set up the environment of Scala and Spark. So these videos will cover detailed topics. So you follow these videos and set up the environment. Okay, and once you set up the environment, all you need is you need to have Scala. Okay, especially for those Windows guys. Once the Scala is installed, you need to create the environment variables. Then only you will be able to write Scala programs, or even will be able to use Scala IDE for Eclipse. You need to have the environment variable. Like in JDK, you need to do the same thing for Scala also. Okay. Actually, that is as part of here. I will cover that little bit later. First, I will go through the concepts and architecture. In this setting up the environment, I primarily focused on the Spark, not on the development environment for Spark using Scala. So sorry for the confusion. So here you already covered most of it. As part of the setup development environment, you already have the virtual machines. If you don't have virtual machines yet, make sure you have. If you have a less powerful computer, and you can even set up Spark directly on your Mac or PC. And here I covered the instructions for the Mac. For PC also, it's almost same. Only thing is, instead of updating a .profile file as shown in this video, you need to set environment variables for Spark Home, and also you might have to set to path so that you can run Spark from anywhere. Once the Spark is set up locally, I'm talking about outside the virtual machine. If you don't have enough capacity on your laptop, if you want to install the Spark locally on your PC, once the Spark is set up successfully, you will, when you launch Spark shell from the command prompt or DOS prompt or terminal, it will launch the Scala-based command line interface for Spark. Okay, if it is set up successfully. If there are any exceptions, let me know. I will troubleshoot and I will try to resolve the issues. Okay, to practice Spark, you don't need to have Hadoop and all those things. Spark is completely an independent module which can work with Hadoop also, or HDFS as well if required. Okay, there are many projects where Spark runs standalone without HDFS. It runs standalone, and typically S3 will be used as the storage. Okay, you need to keep that in mind. Even though Spark is a big data technology, it need not be part of Hadoop ecosystem. Okay, and also I validated Spark shell. You can also run PySpark. PySpark will launch the Spark command line interface in Python context. So if you want to test code snippets in Python, you have to launch using PySpark. If you want to test in Scala, you have to launch Spark Shell. Okay, so that's how you can validate that your environment is ready. So the next topic is concepts and architecture. Setting up environment, again, it's only optional, especially if you don't have enough capacity to set up a virtual machine. Make sure at least you have Spark locally installed so that you can at least practice on Spark as we proceed through the course. At least 80-90% of the topics can be practiced even using your your PC without having any virtual machine or anything. So as part of the concepts and architecture, we'll be seeing architecture, cluster modes. So we will see the overview of the cluster modes, different modules in Spark, accessing the documentation, and some important concepts. Okay, this is mostly, today's class will be mostly theoretical, and the practical session will be started as part of the classes next week. Okay, so this is the main architecture. Okay, you can actually, if the image is small when you are watching, if you want to open it as larger one, you can just right click on it and open in new tab, and you can see here. So if you think from the Hadoop perspective, okay, you will have cluster manager. So Spark is the execution framework. It doesn't have native storage mechanism such as HDFS. Hadoop have both HDFS as well as MapReduce, right? HDFS is the storage and MapReduce is the processing framework. Let us get into few drawbacks with respect to MapReduce before we talk about Spark. Spark is alternative for MapReduce. The reason why Spark is so successful as an alternative is MapReduce works very well for huge amounts of data. For example, take Google, where they process at least terabytes of data on regular intervals, if not daily. Okay, so to process those terabytes of data in timely manner, they built this MapReduce based cluster, and it works well. It is very efficient when it comes to using the resources, and it processes data in a few hours, or whatever their SLAs are. So it works very well for them processing data using MapReduce based frameworks. But take the example of ad hoc queries. For example, you have a data in HDFS and you want to generate reports out of it. One of the ways to do so is, it's very important to understand, one of the ways to generate reports against the data which is in HDFS is by using something called Hive Thrift Server or Hive Connector. Hive acts as a logical database using Hadoop as the storage, and you can connect your visualization tools. What are visualization tools? Reporting tools such as Cognos, business objects, or even JDBC based visualization, D3JS. All these are visualization tools, Tableau, QuickView, etc. Most of these things have the capacity to use JDBC drivers and connect to the source databases and generate reports out of it. And when they connect to the source databases to generate the reports, they automatically generate an SQL, and they use SQL to connect to the source database, and then get the data and then render the reports. That's the life cycle of a report visualization. Okay, so when it comes to Hadoop, you have data in Hadoop. You can create a logical database using Hive, and then Hive have JDBC connectors, and all these, most of the visualization tools, industry leading visualization tools, can connect to Hadoop using Hive. Hive is the database layer. Again, you will understand a lot more details when we dig into Hive. Hive is a logical database on top of data in HDFS, and it provides the connectivity to the external applications also. So typically, people use the visualization tools to connect to data in HDFS through Hive. In Hive, you will create the tables, you can run queries in the SQL format, etc. So these visualization tools can connect to the underlying data in HDFS through Hive, and they can submit the queries, get the data or results, and render the reports for you. So that's how the visualization tools work. They can use Hive. But Hive uses MapReduce under the covers. Even though you write a query, a select query, let's say select count of star from employee table, it's a standard query. And that query will be compiled into MapReduce program, and a jar file will be created the way I have developed the program for top 3 stocks and created the jar and ran the jar file in Hadoop cluster. Same way, Hive will create a jar file based upon the query you have given. It will generate the query MapReduce code when you issue the query and compile the jar file, and that jar file will be submitted as MapReduce job. Okay. Again, MapReduce job is very efficient when it comes to processing tons of data. But typically, to see the reports, we want to see immediately, and we want to look in the ad hoc fashion. So when you use Hive connector, it uses MapReduce under the covers. And when you try to visualize using MapReduce, it takes at least 15 seconds to 1 minute, even if there is only one record in the table, because MapReduce is primarily to process huge amounts of data. It's not for the visualization purpose. The design consideration for MapReduce is to process, not to visualize the huge amounts of data. So there is no viable solution using MapReduce approach for the interactive and ad hoc reporting. That's where a new suite of tools came into picture, and they are Impala, Spark, Presto. So these are all different alternatives for Hive. Instead of using MapReduce, they use something else for the visualization purpose. Okay. So that being said, when you talk, so if you look into this picture, it is saying cluster manager. So the keyword is manager, and then you have workers. These workers can be so many. So this worker is analogous to the worker in Hadoop cluster. They are same. Means if you are using Spark on the Hadoop cluster, each of the slave node or worker node will act as worker node even for Spark. Okay, let me show you by going to the Ambari. Jiva have asked a question. I will come back to that in a moment. Let me finish this. Okay, so now we have Spark in this. And if you look into the details, there is a Spark history server. Again, Spark history server is similar to job history server. If you want to see the already executed Spark jobs details, you have to click on the Spark history server, and then you have the Spark clients. Okay, unlike Yarn, where you have node managers, resource manager, etc. Here we have only Spark history server and Spark clients. The reason is Spark uses HDFS for storage. When set up in the Hadoop cluster, Spark can use Yarn for the execution framework. So Spark can run in the context of Yarn to process the data. Okay. So now coming back to the picture which I'm showing, these worker nodes are nothing but the node managers which are displayed here. When it run in the cluster mode using Yarn, there are different cluster modes which I will cover a little bit later. In the distributed computing paradigm, the worker nodes in Spark is similar to worker nodes in Hadoop, and manager node in Spark is similar to resource manager in Hadoop. Okay, and then this one is client. So typically we will run the programs from the client, and this acts as a client. And on each of the worker nodes, there will be executor. Okay, the executor is nothing but the containers. Okay, when we actually run the MapReduce job, the mappers and reducers will run in the container if they run in the Yarn context. Here, the executor is the the execute from the Spark context, when you are submitting jobs in Yarn, the containers can be termed as executors. So it is analogous to mappers and reducers. Sorry, the JVMs which runs the mappers and reducers. Spark also will run in the JVM. So executor will act as JVM. But in Spark, instead of creating a new JVM or executor for each and every task, like in MapReduce, it reuses the JVM. Okay, and each of the executor will have cache. So details means the output will be cached in this area. If you try to pin the output in the memory alone without doing IO, everything will be in memory. Okay, and then the MapReduce applications or any application that are being executed in Spark will be executed as part of these executors. Once the job is completed, these executors might go away, and a new set of executors will be created for new jobs. Okay, this is how it works. So the main thing which you need to understand is the cluster manager and the worker nodes, which are similar to resource manager and node managers in Yarn. So Jiva is asking, there are Hive 2 do both support for visualization tools? If so, what is the difference between Hive and Hive Server 2? So Hive Server 2 is the component of Hive. Okay, Hive have multiple components. Again, I will cover a lot more details once we pass the Spark. So I will give you a brief idea about it. So Hive is the name of the technology. Hive have many components. One of the component is Hive Metastore, which is nothing but a relational database which will store the metadata of your tables. And the second component is and the second component is a Hive execution engine, where it will actually compile your query into SQL, and then it uses Hadoop itself to process the data. And the fourth one is Hive Server to provide connectivity to the external applications. Okay, so you should compare between Hive Server and Hive Server 2. Hive Server is legacy, and Hive Server 2 is the latest one, which can provide connectivity to the external application. Okay, you should not compare between Hive and Hive Server 2. Hive is a high-level tool in which there are multiple components. Those are Hive Metastore, Hive Server, etc. Okay. So now let's go back here. So this is the high-level overview. It is very simple and similar to Yarn, and Spark is alternative for MapReduce. When it comes to programming and also execution, Spark is alternative for MapReduce. So now we will talk about the cluster modes. You can run Spark in local mode. So when I actually start Spark here, okay, when I run Spark shell, by default, when I install Spark as standalone, it is similar to this. So it is actually running in the local mode. If I say Spark shell -- master local, it will run in the local mode. Okay. If you want to change the mode, there are other modes. So for the development purposes, typically we will use local, but for the production purpose, okay, either we use Yarn or Mesos. Yarn, you already have brief idea. Mesos is completely Spark-based execution framework. So as I mentioned to you earlier, Spark is a completely independent module which can work in the context of Hadoop. Okay, it can also work in the other with other technologies also, especially when it comes to storage. Spark originally started with S3 and local file system, and then looking at the success of the Spark, the Hadoop community started working with them, and they have tightly integrated with Hadoop. Even Spark use the Hadoop binaries itself when it comes to dealing with the files, even though it works with the other file systems. They inherited the code base from HDFS, and they use as part of their Spark code to process the data. So internally, it uses Hadoop file system extensively from the day one to process the data. But that doesn't mean that it has to run on the Hadoop cluster itself. It can run on S3, it can run on local file system, it can run on any file system. Okay, for file system, it is completely transparent and it can work with any file system. For the execution purpose, they actually started with Mesos and Spark native. So I think Mesos itself is Spark native. So using Mesos, so we have to configure what is the master, what is the slaves, and then it will actually bring up Mesos based cluster. There will be daemon process which will be running, and then you can submit the Spark jobs. When Cloudera and Hortonworks started seeing the success of Spark, they started working on integrating Spark with Yarn, and they are moderately successful. A lot of clients are not very happy when they use Spark with Yarn. They feel it is slower compared to Spark with Mesos, but eventually things will catch up and Spark will work effectively on Yarn also. So it's very important to learn from the Yarn. From developer perspective, it actually doesn't matter whether you are running against Yarn or Mesos. As a developer, it doesn't really matter. Okay, and then standalone. What is standalone is, let's say you developed a program and you want to see how uh, it run when it is deployed in the cluster. Okay, so for that purpose, when you go to the Spark binaries, so this is my base directory, users dgajraju Spark. In this is the Spark complete application layout. You can see a bin directory and you can see a sbin directory. You can go into sbin and ls-ltr. If you want to understand how how your Spark jobs will work, or if it works at all or not in a cluster, you don't need to set up cluster on your machine. What you can do is you can say start master.sh. It will start in standalone mode. So it's like a pseudo cluster mode, and then you can actually submit jobs against that master. So you will get an IP address which is localhost and a port number. When you start the server, it will give you the port number, and using that information you can submit your Spark job as you actually deploy it in a cluster. It is for development purposes. Sometimes what will happen is code will work in local mode, but when you try to deploy in the cluster, it might not work. Okay, so to overcome some of those issues, you can start your server in standalone mode, validate it. If it is working, then ship it to the higher level environment to submit the jobs. Typically, when you actually work on project, you don't need to do that. You will have a development environment. You will develop locally, and you will test your code in the development server, which will be similar to the production. If they are using Yarn in production, they should use Yarn in development and testing also. And then you can submit your jobs in the development first. If it works fine, then you can release it to the QA and eventually to the other environments. Okay, so those are the different cluster modes where you can actually run this Spark jobs. And for the documentation, I think I have provided the link for the documentation. No, I will come. It's better always to refer to the documentation of the corresponding version which you are exploring. At this time, I'm explaining using 1.6.2, which is the latest Spark version. There is Spark 2, which is significantly different from 1.6, but still it is not extensively used in the production environment. As there are significant differences, you have to transition to Spark 2 with a caution. Okay. Because Cloudera or Hortonworks, which are the leading vendors in big data, might not follow the Spark versions that quickly and move on to Spark 2. So you need to be familiar with the current version, and slowly you have to update your skills to get to the Spark 2 eventually by the time it catches up. Okay, anyway, So now I am actually talking about Spark 1.6.2. So this is the link, sparkapache.org docs 1.6.2. You can go here, and here you can see the cluster modes. So you can run on Yarn, you can run on Mesos. There is Amazon EMR with Spark. You can run on that also. That's why they are highlighting it as a cluster mode as well, and then standalone. Okay, so if you want to get more details, you can go here and explore it a little bit further. But as a developer, you don't need to spend too much of time in this area at this time. Okay, so the next important topic is different modules in Spark. So if you see this picture on the right side, let me open in a new tab so that you can actually have the bigger image. So you see something called Apache Spark at bottom, and you have Spark SQL, Spark Streaming, MLlib, graphics, etc. So this Apache Spark is called as core Spark. Okay, so it is nothing but a bunch of APIs, and they are called as transformations and actions. So if you go to this, if you go to programming guide, and if you go to Spark programming guide, whatever material uh, that have been mentioned here, it is primarily for this module, Apache Spark, which is nothing but the core Spark. And most important things which you need to focus is transformations and actions. Okay, so over time you will learn this as many as possible within this. Yeah, I will not be able to cover all this all these topics also, but I will try to cover as much as possible, at least 60-70% from the project perspective, how to define a problem statement and decide which transformation and which action should use, and how to implement using programming language such as Scala or Python for that business requirement. So from that perspective, we will cover, and we will try to cover at least 15 to 20 different transformations and actions. There are handful of them. Once you will get the foundation, you will be able to understand those other 30-40% of transformations and actions very easily. And some things are self-explanatory. You will understand by just reading them. Okay. So that constitutes of Apache Spark, the core Spark. So core Spark is nothing but a bunch of APIs, and you can see that you have some of the transformations such as join. There's a transformation by name, sort by key, aggregate by key, reduce by key, group by key, etc. Okay, so Spark is relatively much simpler to implement compared to Java. I will explain that with a simple example. We have seen the top 3 stocks, okay, and the amount of effort which I have put to explain took almost 1.5 hours, and there are at least 10 different programs and hundreds of lines of code just to get those top 3 stocks for each day, right? If you want to implement using Spark, so this is the code which you need to write. Okay, so here we are trying to read the data. We are trying to group by the date, and then we have developed a simple function called getOpen. This is Scala function, and then we are invoking that function using as part of the Spark-based transformation, and then we are printing the output, or we can even save into HDFS with a simple one-liner. So with this little amount of code, you can accomplish so much stuff. Okay. Still, even though it is a lot more easier compared to Java, when it comes to processing the structured data, people are very comfortable using SQL compared to writing a complex writing programs using any programming language. It's better to use SQL. And also, as I have mentioned to you earlier, visualization tools typically understand SQL to provide the visualization capabilities to the customers. Okay, so to provide the connectivity to the visualization tools, Spark have come up with the Spark SQL module. Okay, as part of the Spark SQL module, you will have Spark Thrift server, similar to Hive server, and using Spark Thrift Server visualization tools can connect to Spark using JDBC drivers, JDBC or ODBC drivers, and then you can use your visualization tools such as Tableau to drag and drop the tables which are created as part of Spark SQL, and you can start designing your reports. And when the report is submitted, it will generate SQL using this Spark SQL. It will go to the data in HDFS or S3, and it will generate the reports for you. And the reports will be much better compared to using Hive as connector to visualize data in Hadoop. Okay, and then Spark streaming. At times, you might have to get data from different sources, and you want to process the data even before storing in the target. So the source can be a streaming weblog. So let me give you an example here. For example, if you go to Amazon.com, I just visited Amazon.com now, and I am trying to buy iPhone 7. Okay, I search for iPhone 7, and here I want to get 128 GB, and the price is 1124. I felt it is high, so I moved out of this website. Okay, and even though I didn't buy, I coming here and doing some activity on the website is an important information for Amazon to make certain decisions in future. What type of things, what type of activity I'm doing, if they can capture, they can recommend better things for me in future, or if not me, for customers like me, right? So typically people tend to store all this information in the database, but if Amazon starts storing this information in the database, what will happen? Their databases will explode. Okay, and this is not very important information to invest millions of dollars and store this information in the database, because it does not add much to their bottom line. But at the same time, if I buy this product by checking out, that information has to be persisted in database. Okay, so when I actually check out and buy, most likely those transactions will get into the database. But when I perform certain activity, here I searched for iPhone 7, I see the results, and I clicked on iPhone 7 unlocked phone 128 GB. I went up to checkout. Okay, let me add to list. Okay, it is asking to log in. I don't want to do that now. So let's say I add it to list and I went to the cart and then I discard it. So there might be something that might be happening from users like me, which Amazon want to capture, and this information should not go into the database, because I have visited 4 or 5 different pages, and then I discarded it. I didn't do any transaction with Amazon. So instead of storing this information in database, what Amazon do is, along with the other application related information, Amazon locks this information um, into their web server logs. So I will show you the example how it will look like. So here I'm trying to connect to my website. Okay, in that case, yeah, let me do this. Okay, let me show you here. So Cloudera Quick Start VM comes with a tool called gen_logs. Okay, so you can actually run a command. If you are using Cloudera Quick Start VM, you can run a command called startlogs.sh. Startlogs, not startlogs.sh. Okay, now the logs are being generated, and you can see tail underscore logs. And you can, it is just a simple application, a Python based script which will generate simulated logs for our retail data set. Okay, now if I kill this, and if I try to review the data, you can see that what all uh, from which browser the requests are coming. Okay, so this is the browser, Mozilla on I don't know why they have both Chrome, Safari, and Mozilla. I'm not 100% sure. Probably I might be misinterpreting this one. Okay, but it is giving some information with respect to browsers, and most importantly, it is telling which page uh, uh, is being visited. And here you can see the IP address also. Okay, so using IP address, we can actually get the demographics from which area these guys are trying to uh, search for a particular product. Using this information, they can probably tell which browser they are trying to use. Using this information of the same IP address, what all pages this user is visiting, and whether he is checking out or not. All the details can be captured, and all the information will be captured anonymously. They are not actually capturing the names of the people. Sometimes when you log in and do certain activity, they might even get the information about the user ID as well, but they don't capture any confidential information. But they actually get your information into weblogs like this. So when the weblogs comes like this, okay, it might not be a good idea to store this entire information into HDFS. Okay, if you want to have it for a backup, that is fine. But if you don't want to use it for backup, and especially if you want to store into technologies like HBase, Cassandra, etc., to provide the visualization, what we can do is capturing the streaming data. We can apply certain transformations. So, for example, this is the IP address where he added to cart at this level, and probably somewhere down he might check out. So I can actually pool the data for 5 minutes or 10 minutes or 1 hour, whatever timeline I feel comfortable with respect to my SLS. I can pool that information, and then I can run some analytics, uh, capturing this IP address as key, what all activity this IP address have done. And then if I want to if I want to extract some relevant information from this activity, I will apply those rules and extract the relevant information and store that relevant information in the a NoSQL database or Hadoop, whatever it is. Okay, so to process such kind of data, you can use a technology called Spark, or a module called Spark Streaming, which is part of Apache Spark. Okay, so Spark Streaming it cannot read the data directly from the weblogs. We use either Flume or Kafka to source the data from the weblogs. Flume or Kafka run in the form of agents. It can fetch the data. Typically, we don't do transformations in tools like Flume and Kafka. We just connect to the web server logs, pull the web server logs based on certain rules, extract the data, and hand over that data to the some target or sink. That the target or sink can be Spark Streaming layer, where Spark Streaming can wait for new files that are being generated by data extraction tools or ingestion tools such as Kafka or Flume, and then perform some real-time analytics, massage the data, transform the data, extract the relevant information, and pass that relevant information into the database, which will support the reporting layer. The database can be Cassandra, HBase, traditional RDBMS, or it can be Hadoop also. So Spark Streaming is that layer in between the data ingestion tools and the database, where you can actually perform the real-time analytics. And alternative for Spark Streaming are Storm and Flink. These are the alternative tools for Spark streaming. You have to use one of these technologies to run streaming analytics, and Apache Spark have a module for doing the same. And then graphics is, if you want to represent data in the form of graphs, then you can use graphics. You can actually process it has APIs where you can quickly transform your data into graphs and do some visualization, not visualization, but analytics on top of it. Okay, I'm not 100% sure on graphics. I haven't explored it in detail, but it's primarily to process the data in the form of graphs, and it is a module in Spark which runs on top of core Spark. And then MLlib is a machine learning APIs. So Apache Spark have the core APIs, and machine learning have algorithms such as the classification and many other things. Again, I'm not very sound in machine learning. And if you want to use Apache Spark in the context of machine learning, you have to understand the machine learning libraries, but it is built on top of core Spark. So if you learn core Spark, understanding other modules or using the other modules will become easier. So focusing on the core Spark is the most important thing you need to do. Okay, and there are other modules also, like Bagel and R. Graphics and Bagel are two alternatives. Bagel is primarily developed based on Google white papers, and R is Spark also have a module which can run R scripts at scale. So it converts R script into core Spark APIs, and it run the applications, R-based applications on Spark. Okay, so these are different modules which are available in Spark. Very, very important to understand these different modules, but you should focus primarily on the Apache Spark, and then you can change the dimension depending upon the requirement for your project. If you don't know the core Spark, and if you directly get into the MLlib, you will be lost very quickly. Okay, so any questions here about the modules? Sure, Ramesh. Actually, there is a module in the course, visualization using Tableau. I will cover at that time. Okay, but I will briefly give you an idea. So you have data in HDFS. You have a Spark which will process the data. Okay, you can process huge amounts of data by using Spark submit command. Okay, whether it is Mesos or Yarn, it doesn't matter. You typically use Spark submit to submit a Spark job. But for the visualization purpose, you should not run in the form of offline jobs. You have to interact with the reports. You should slice and dice. You have to change the parameters, and your report should refresh. In that context, you cannot use the way you typically submit the job, such as Spark submit. Instead, you need to have a different layer altogether. Okay, so Tableau, I will use the Tableau as an example here. Even when in the relevant module also, I will use the Tableau or any BI tool. They are capable to connect to any database using JDBC, ODBC drivers. I hope you are aware of that. They use either JDBC drivers or they use ODBC drivers to connect. Okay, so to facilitate that connectivity, in Oracle, you have listener, where you can connect to the so using the connector, you will connect to database through listener. Listener is nothing but a web server or a software process which will be running all the time on the Oracle database that is set up. Take any example, take any database. There has to be something like that, where a software process is up and running all the time, which will provide the connectivity to the external tools. Okay, and all the BI tools uses those technologies such as listener for Oracle to connect to the underlying database, and they need to have a jar file such as JDBC ojdbc.jar or ODBC driver to connect to the database through that listener. So first you need to download the Tableau desktop or Tableau server, and then you have to download ODBC or JDBC drivers. Okay, and then you have to provide the IP address and port number where the technology similar to listener is running. Technology similar to Oracle listener in the context of Spark is called as Spark Thrift server. Once you have the Spark Thrift server, you can actually issue SQL type of queries in Spark using any external tool, and that's how the visualization tools work through JDBC, ODBC drivers through Spark Thrift server. They are able to submit the SQL queries which are generated by the design of your report. That SQL query will use a Spark Data Frames API or RDD API, do the processing, get the data as quickly as possible because the processing happens in memory, and return it to the visualization tool, and the visualization tool will render the report for you. So that's how the whole life cycle works. If you have any follow-up questions, we will talk about it a little bit later. I'm not 100% sure, Nagaraj, about named pipes. If it is it's a good information to know. Okay, I haven't worked on SQL Server very extensively. Okay, now accessing the documentation I have already covered. Go to Spark Programming Guide for the core APIs. And then for rest of the APIs, click on the programming guides. You can see here there is documentation on Spark streaming, documentation on data frames, datasets, and SQL, MLlib, GraphX, Bazel, and also Spark Car. I'm sorry. Okay. And then important concepts. The building block of Spark is RDD. RDD is nothing but a resilient distributed dataset. And then transformations and actions we will see as part of the main course. Shared variables also we will see as part of the main course. So let me explain what an RDD is, and then we will wrap up for today. My throat is not very good, so I would like to close it a little bit quickly today. But I will try to troubleshoot some of the issues after I have explained the RDD. Okay. Okay. So let's take the file system. Okay, this file system can be HDFS, S3, local, or any Spark supported file system. Okay, so if it is HDFS, okay, typically the data will be in multiple nodes. And if you take the example of 1 GB file, 128 MB as block size, replication factor as 1, there will be 8 blocks, B1 to B8, and these 8 blocks will be distributed on the cluster. And then you have Spark, and you have Spark worker nodes. If it is running, that's fine, Raj. I will just finish this very quickly. It will not take very long time. Okay. So if you have the Spark cluster here, and and so when it comes to Hadoop, Spark cluster, uh, sorry, when it comes to Spark running on Hadoop, okay, the Spark components and Hadoop components will be sharing the resources the way I have shown here. If we go here, HDFS is running on all the nodes, okay. Yarn, which is node managers, is running on all the nodes, right? And Spark uses Yarn itself to process the data. So here, the workers of Spark also run on the same data nodes, but from the file system perspective, okay, the Spark is a client to HDFS. If it is S3, it is client to S3. If it is local, it is client to local file system. Okay, so depending upon the underlying file system, the behavior will change significantly or considerably. If not significantly, considerably. Okay, so now for this one, for Spark, we are trying to, let's say the file name is F1. Spark will try to read file F1, which is in HDFS. And when we try to process the data, when we actually use this command called sc.textfile to read the text files with text data, we use sc.textfile API. Sc is nothing but Spark context, which is a variable which will be created when you launch Spark. We don't worry too much about it. Primarily focus on this text file. Text file is nothing but a API or function which takes the path as parameter, and what it will do is it will actually create a RDD. So here, if I log into the cluster, run Spark shell, okay, one thing which I observe is people don't follow what is happening on the screen. Okay, and in the end, if they see the positive message, that means they think that everything works, and then things will not work as expected. So if you see here, I when I actually launched this one, it has shown something like this, especially from the people from non-Java background. People from non-Java background, they don't know that this is an exception. Okay, they just ignore and they start working on it, and they will run into some surprises. And without troubleshooting the issue, when they run, when some things will work, some things will not work. When some things does not work, and when they try to troubleshoot using the final outcome of the final command, then they run into huge confusion. They cannot ask the questions, right questions in Google, and they get overwhelming responses from everywhere. Each one gives different direction, and you will be lost. So until you master on a particular technology, you should focus on the output that is being generated when you launch a command until you understand it, at least up to significant extent. You should focus on what is happening. Okay, here you can see there are a bunch of exceptions, and all the exceptions are saying address already in use. Address already in use. Address already in use. Okay, so the reason is when someone starts the Spark shell, by default, it try to launch a web service locally because I think this is running in standalone mode, not in the local mode. When Spark shell launches in the standalone mode, it try to connect with it try to start a web service using default port. The default port is 4040, and this cluster is being used by many people, and someone already might be running Spark shell like me. Okay, so it first starts with the 4040, and if the address is already in use, it will again retry with some other port. Again, it tried with 4041. Again, someone else is using that port also. So like that, it has retried every time using a different port. So even 4043, it's the same issue. And then it actually started on 4044. Okay, so you should understand what is going on. Sometimes it might give a different error, and it might not start the service at all. At the time, you might see exceptions here, but for non-Java developers, even if the information is like this, okay, even if the information is like this, they don't know that it's an exception, especially for the mainframes guys. You should scroll up. Okay, in Java, exceptions are returned. Um, in Java, exceptions are written in the form of stack. Okay, stack is um, last in first out LIFO algorithm. So you have to go to the beginning of the issue and see what is going on. Here it will actually throw the exception. Okay, it is very important for the non-Java developers who don't know how the exceptions are thrown in the uh, Java or any Java-based programming languages. Okay, so very important to understand. Here it started fine, but it started with a 4044 port number. Yes, Nagaraj, you can actually specify the port when you try to launch the Spark shell itself. Okay, but this is not a major issue when it comes to working on the lab. In the production cluster also, in production cluster you never launch Spark shell like this. In development cluster also, even if it do like this, you don't need to worry much about it. Okay, if you want to avoid, no matter what you do, even if you specify the port, if that port is being used by someone else, then again you will run into the same issue. So just launch it. This issue you can ignore. But what I'm trying to emphasize is you should try to understand the information and make sure you understand it is not a actual issue, and then you can proceed further. Okay, so now Spark is started. To validate, you can type sc and hit enter. If the object is created, you will get the data type of it. This sc is a implicit object which is created as part of the Spark shell. When we launch the Spark shell, it launches using Scala, and it will create this object called sc. Okay. Now I'm trying to read this data. Okay, sc is of type Spark context. I will explain what is context and config when we actually get into the main topics. Here we are primarily focusing on RDD. RDD stands for resilient distributed data set. The keywords are resilient and distributed. So you can see the data type of this NYSC is of type RDD. What is an RDD? It's a resilient distributed data set, which is nothing but a collection. The difference between typical collection and RDD is the distributed and resilient. When it is distributed in the memory of the executors. So it will when we actually start a Spark shell, or when we actually submit the Spark job, it will use the default number of executors. Okay, if you want to override, you can override. I will explain how to override all those things a little bit later. So you can specify the executors, and it will try to use those many executors to start the job, and it will try to reuse those executors to complete the job. So each of the executors will have something called cache. So when we actually go to the architectural diagram, here you can see that there is an executor on each of the worker node. Okay, and those executors will be specified when you actually submit the job, and you have something called cache here. This cache will be used. It is nothing but in memory by default. Sometimes you can use file system also up to some extent. Once it reaches certain threshold, if you want to use file system rather than running into out of memory issues, you can specify that also. But default, everything goes into the memory. So the major thing is the collection is not only distributed, but it is also in memory. Okay, that covers the distributed data set. What is resilient? Let's say one of the executor is crashed. There are 10 executors when we start the job to process, or 8 executors created when we start the job to process the data. Each executor will have will create a copy of the collection by reading data from the input path, and one of the executors is crashed. That means whatever processing that is done thus far is gone, and also the cache, the data which is in cache is also gone. So what Spark will do is it will rebuild those executors which are crashed, and as part of the rebuild, it will also rebuild the data set which is lost. Okay, that's what makes it resilient. So resilient distributed data set means that it's a reliable in-memory distributed collection is known as RDD, or resilient distributed data set. Now, going back to the picture here. Okay, we have the files. We have a file F1 on HDFS, and we try to read it to process the data. Okay, where is the pen here? So let's say I have given 2 executors to process the data, E1 and E2. I will get back to that in a moment. Nagaraj is asking, does it replicate? I will get back to that. So here you have the file F1 with of size 1 GB and 128 MB as block size. So there are 8 blocks. Okay, especially when it tries to read the data from HDFS. Now we have 2 executors, right? So what it will do is it will cache approximately half of the data in each of the executor by reading from HDFS into the memory of the executor. Okay, and then there will be tasks to process the data. So from HDFS, it got into the memory, and the tasks will eventually process the data. So that's how it works. When it comes to running Spark on Yarn, these executors might run on the same nodes where your data is. So it might try to leverage data locality up to some extent, but data locality is not very important because IO will be done only once, and then it will try to use the memory until the processing is completed. But whenever it has to do the IO, it can compromise data locality when it comes to Spark, but it is not very significant here. Okay, so that being said, let me take this question from Nagaraj. Does it replicate the collection? No, it does not. The replication fault tolerance of the actual files is taken care at the HDFS layer. So Spark is not a file system, it's a processing engine. The way it processes the data is first it will copy the file into the memory, and then it will try to use memory as much as possible to process the data. So the replication is the file system level concept. How does it rebuild on failure? It's a very good question. It will go to the HDFS again. It knows the master process knows which blocks these executors read from HDFS, and if this executor is gone, and if it has B1, B2, B3, and B4, then it knows. Yeah, it's based on DAG. I don't want to get into the terminology here. Hence I am explaining the actual concepts. So it will actually, if it is crashed, the master process knows which all blocks are being lost, and then it will try to rebuild. Okay, so I'm not very familiar about DAG. So even as part of the course, I don't focus on DAG much, but this is how internally it works. don't worry too much about those buzzwords. Rather focus on the APIs. That is a lot more important. Okay, DAG and all, it is very relevant when you get into the, once you have the foundation, when you try to start developing the applications to uh, uh, to uh, to perform to troubleshoot the performance tuning issues. In that scenario, you need to understand the relevance of DAG significantly. But to kickstart, don't get into those things immediately, because it can cause confusion and you will lost a lot of time understanding those not so relevant concepts. Okay, so in future I will have a performance tuning workshop, probably 3-4 months down the line, and then I will talk about DAG and all those things. So just to confirm, if the job runs out of memory, it will start to dump to file system and not crash. Very good question, Brent. By default, no, it's not the case. So let me show you here. So when you create the RDD, you can specify the storage level. The default is memory only. So if it runs into out of memory, it will fail. If you say memory and disk, then it will not fail. It will keep the RDDs onto the file system. And there are few other options also. You can also store the RDD completely onto disk as well. Okay, so very good question, Brent. So any other question? So for today, that is it. So make sure you have the environment, and as part of the next class, I'm fine now. My throat is a lot better, so you can ask questions. I occasionally get that 5-minute, 10-minute problem, and once that is passed, it is fine. So if you have any questions, you can ask me. So as part of the next class, we will start with I will not get into the details about how to set up Scala and FBT, all those things. We will directly get into context and configuration. So make sure you go to these 3 exercises and set up the environment. Okay. If I start doing that, it will take at least 2 classes for that itself, and it is of not much use for you to better to get better productivity. Let's start with context and Spark configuration. Spend the next 3 days time, and make sure you have the environment. You should have something like this. This is Eclipse, and when you actually go to Eclipse and go to Window, go to Perspective, open Perspective, Other, you should see a Scala perspective, and you should be able to write the Scala program. Okay, so you should be at that level. If you run into any issues, I can troubleshoot towards the end of the classes or the next week and try to resolve those issues. But at least you should make an attempt to build the environment so that you understand how the projects are built in real time, rather than just using Spark Shell. It's better to use Scala, Scala IDE for Spark, Scala IDE for Eclipse, and start using this one so that you understand the development process also. No one uses the command line like this to develop the applications. Okay, so there is another question from Shiva. What if master process fails which has executors information? So it is same as the MapReduce. Again, very good question. It has to restart the job, or you have to restart the job by yourself. Okay, typically most of the cases it will retry at least once or twice. If it does not, if it fails for due to some, so very good, actually it is very good question. I need to cover the fault tolerance in Yarn also. I haven't covered as part of yesterday's class. So today we will cover both. As part while answering this question, I will cover both Yarn and Spark, how the fault tolerance works. So fault tolerance, when it comes to the execution framework. It can happen at the first of all, let us understand where faults can happen. The fault can happen at a task level, or a task manager level, or a complete cluster manager level. So task is nothing but mapper or reducer when it comes to map reduce. It's a executor task when it comes to Spark. When it comes to task manager, it's the failure of components like node manager. When it comes to the complete cluster manager, the example is resource manager. So first we need to segregate these three. First is the task which actually process the data. Second one is task manager, such as node manager. Third one is the actual cluster manager. So Ramesh also asked a very relevant question, heartbeat mechanism. I will cover that also as part of this answer, which I'm going to give. So when it comes to executors, whether it is Spark or MapReduce, because we are talking in the context of yarn, if the task is crashed, it will be restarted on other within the same executor. So here in the Spark, the failure could be in a task level, it could be at the executor level, right? Yeah, so if a task fails within the executor will try to restart that task alone and try to process the data whatever the originally the task was processing. If the executor itself have failed, the executor will be failed over to some other node which is surviving at that time. If the master itself fails, then your job itself is failed, and it can happen for several reasons. Any of these errors can happen either due to a hardware failure or a software bug. If it is a software bug, no matter how many times it will restart, it will run into the issue. If it is a hardware bug, when it tries to restart in a separate node, which is healthy, then it will run without any issues. So typically, whether a task is failed or executor is failed, or from the MapReduce perspective, if a map task or reduce the task fails, it's a task level failure. It can be restarted on a different node easily. So it will take care automatically. It will just restart that task on a when it comes to Spark. When it comes to when I'm talking about task from the yarn context, the task can be executor itself. If the executor fails while submitting the Spark job, it will try to recreate the executor on a different node to make sure any hardware failures to overcome any hardware failures, and it will try to run whatever tasks that are being executed by the executor before it crashes. Okay, it will try 3 or 4 times. By default, it's 4 times. If it goes beyond 4, most likely it could be due to bug in the code. It's highly unlikely that 4 different nodes fail at the same time. So most likely it could be a bug in the code, and then it will give up. The executor or the task will not be restarted, and job itself will be marked as failed, and the developers have to troubleshoot the issue and come up with the solution. Okay, that is the case with the tasks. Most likely, if there are bugs that can cause the failures at the task level, whether it is MapReduce or Spark, and it will retry 4 times, and it will fail the complete job. When it comes to master, okay, here master is there is a job master which is application master. Okay, the default retry is 1. So when you actually do the Spark submit job, it will also create an application master, and then it will create the executors. The same way when we submit the MapReduce job, it will create the application master, and then it will create the mapper tasks and reducer tasks. Similarly, is the case with Spark job. When the Spark job is submitted, the master for that job will be an application master. Okay. By default, the retries on the application master is 1, and those are all controlled by parameters. If you go to Ambari and click on yarn, go to configs, Okay, and search for am dot. Yeah, here yarn resource manager am max attempts. So application master max attempts 2. So it will only retry one more time, and if it fails, it will fail the complete job. Okay, but when it comes to the task manager or the cluster manager, such as node manager or resource manager failure, then it will not try to restart. Okay, what will happen is it will blacklist. So if it is a node manager failure, it will blacklist that node, and no more executors or map reduce tasks will be executed on that node. If the resource manager itself fails, then your cluster is down and you will not be able to submit any jobs unless you have the high availability at the resource manager level. So I will I will go to your question in a moment, Jiva. Let me recap what I have explained. Okay, so the failures happen at different levels. The failure can be at a task level. The failure can be at a job level. Okay, in yarn context, the job is controlled by application master. So if a task fails, it will try to retry 4 times to process the data to see that there are no hardware failures. And after 4 retries, it will mark the entire job as failed, and your application master is also will be killed. If the application master, which is the job level master for the life cycle of the job, fails, then in this case it will only retry twice. Default is only one. It will not even retry. Okay, it will just retry twice in this cluster, and if when it tries the second time, it will restart the entire job. It will discard whatever processing was done earlier. It will restart the entire job, and it will process the data, and it will do whatever it has to do in that job. Now coming to the framework, such as yarn framework itself. If there are failures on the node manager or resource manager, if a node manager goes down, the node will be blacklisted, and resource manager will not submit application masters in that when the job is submitted. And also application masters will not submit map tasks or reduce tasks or even executors for Spark jobs on those nodes where the node manager is not running. So how the node manager, how the resource manager will determine whether the node manager is running or not is by using the heartbeat mechanism, which was the question of Amesh. So node manager will start heartbeat, will keep sending heartbeat every minute, and if node manager goes down, then the resource manager will not get the heartbeat. It will wait for 10 minutes. If there is no heartbeat for 10 minutes, then the resource manager will blacklist the node manager, and it will not submit. It will not try to submit any jobs on that node manager. Okay, so that's how the heartbeat mechanism works to understand the state of the cluster or the components in the cluster, such as node managers. So Jiva's question: do the tasks within the executor work parallel or sequential? It's a very good question. It's a very good question. Yes, it runs in parallel. It's not sequential, it's in parallel. So at each executor level, you can specify how many tasks should it run. And as per my knowledge, it runs in parallel. But I'm not 100% sure. I will check. I will check that, and I will get back to you as part of the next class. It's a very, very good question, Jiva. So any other question? Before taking the other question, let me ask you guys if your Eclipse is working as expected, because even Scala IDE works on top of Eclipse. If your Eclipse is not working as expected, then you might run into issues with respect to developing the Spark applications using Eclipse. You might or you might not. So make sure you have the Eclipse environment set up. If you don't have, if it is still running into issues, then let me know. I will try to troubleshoot. On my Windows laptop, it is working fine, but couple of guys have complained. Yes, Raj, it is same as Eclipse. I have, yes, Nagaraj, Spring also uses Eclipse internally. So Jiva's question is, local mode means yarn client mode are different. Local mode is completely different. So there are 4 modes. We have local, we have yarn mode, we have mesos, and we have standalone. Okay. When it is local, it does not try to connect to any server. It will start the server for that session. It will run, and it will come out of it, and the server will be killed. It is primarily used for the developer purposes. And then standalone. Standalone, you have to start a Spark-based server, which I have shown under the directory has been. Okay. I will come back to that question, Raj, in a moment. So, Jiva, standalone mode is also typically used in the development purposes. To run in yarn mode and mesos mode is different. Typically in production, we will either run the Spark jobs in yarn mode or mesos mode. With mesos mode, you have to say what is the mesos server. In yarn mode, you just have to say that I want to run in yarn, and both have to be integrated in such a way that the Spark have the visibility to the configuration files of yarn, and using that information, Spark can connect to yarn. You don't need to specify where your resource manager is running. You just have to set environment variables properly, and it will take care for you. Okay. So local mode is not yarn client mode. It is completely different. We will use local mode to run using Eclipse, but when we deploy on the server, we will actually use yarn client mode, and you will see those things as we proceed in the course. If you are curious and if you want to understand, let me. Yeah. So you can go to this develop Spark apps with Scala IDE. And you can scroll down. And you can see here. So this is how you run in yarn client mode. And this is how you can specify executor memory, total executors, etc. Okay. Here it's I have developed in multiple lines, so you have to have backslash. So there is nothing like yarn cluster mode. Okay. When you run in yarn mode, the master parameter should be yarn, and then as part of your application, you have to specify that you want to run it in yarn client. So if you go through this code, the way it will work is, let me show you. So here, this is where you will specify whether you are trying to run in yarn client mode or mesos mode. If it is mesos, you just have to give the mesos server IP address here. If it is yarn, you have to pass yarn client here, yarn client string here. So what I'm doing is, while executing the job, I am passing the mode as parameter, which is yarn client. Okay. And then this is the input path from which I want to process the data. This is the class name which I'm trying to execute. This is the jar file name. And when we try to run in yarn mode, we have to say -- master as yarn. This parameter is mandatory. Otherwise, it will try to use something else. So there is nothing like yarn cluster mode or yarn client mode. There is only yarn mode. And when you try to run in yarn mode, you have to specify master as yarn if it is not default. And also as part of your application, you have to say yarn client so that it run in yarn mode. Okay. If it is mesos, you just have to pass mesos colon / and the mesos server IP address and port number. Okay. So again, a lot of 3 or 4 people have complained about STS and their inability to run MapReduce jobs. Okay, I'm still troubleshooting on my Windows laptop. I'm trying to reproduce. I have 3.7.3 or something, and I'm able to run the MapReduce jobs without any issues on my laptop. But most of the all the issues are on 3.8.1. So I'm in the process of setting up the environment with 3.8.1, and I will troubleshoot the issues. If it is a common issue, we will look for an alternative. If it is Eclipse related issue, if not, the one thing you need to do is, even if it is failing, as I have explained yesterday, build the jar file of the application and run the program on the cluster, a simple word count program on the cluster, which is built using your Eclipse, and then using the jar file which is built using your Eclipse, and then run on the cluster. If it runs fine, that means it could be some issue. There could be some issue with respect to Eclipse, and Scala might work without any issues. You can proceed further. Meanwhile, I will be troubleshooting the issue. But if you run into some other issues such as JDK tools and all those things, let me know. Those issues have to be fixed immediately. Otherwise, you might have the side effects when you try to use Scala. Okay, because Scala is dependent on Java and Maven extensively. So if Eclipse with Maven does not work properly, that means you might have some issues when you try to develop the Spark-based applications using Scala as programming language, using Scala IDE for Eclipse. Eclipse and STS are same. STS is nothing but a Spring version of Eclipse with Maven plugin. Okay, so that being said, thank you very much for joining the session. You can also ping me offline also if you want me to troubleshoot the STS issues. I will be glad to do so, and I will try to resolve those issues as quickly as possible. And next week is very, very important. It is the most important component of the entire course. So make sure you join the classes and practice well for next couple of weeks, so that you master over Spark. Okay. That being said, thank you very much. Have a nice one. Bye.